increase biomass production. So you apply fertilizer, you get more clippings. And mulching clippings increase biomass production. Recycling your clippings, you get more biomass produced versus removing your clippings. Okay, runoff. So this is our runoff data. We have runoff events over the course of a frozen period of soil. We have our various treatments, the no fertilized, the N and K only, so the no phosphorus, the 1 pound of P, and the 3 pounds of P. You can see that most of the time when we got runoff events, that was fertilized with the high rate of phosphorus the previous year, we got a tremendous amount of phosphorus moving off those sites when the ground was frozen, but we also got phosphorus moving off even with the control no fertilized plots. You know, it really happens during this period of time. Snowmelt occurs, ground is frozen, leaf tissue is broken apart throughout the course of the winter. We get desorption of phosphorus in that upper soil profile, and leaf litter that was left on from leaf drop from trees in the fall. All of these things contribute to soluble phosphorus moving off the landscape during the spring snowmelt. Here is the runoff data for unfrozen soil in 2005, same treatments, and you can see, except for one event over here, we had no differences between any of the treatments. As a matter of fact, the amount of phosphorus being lost was very minor in the scale of the whole year when you take it into account for the whole year. When we did get that runoff event in the fall of 2005, we had 8.5 inches of rain over a 3 or 4 day period, and we got a tremendous amount of movement of nutrients. Okay, so looking at this on the scale of the entire year, we have our frozen area. Frozen ended, it kind of looks like it's almost June. I always start off some of my talks that, you know, the ground just thawed in Minnesota and it's August or July and we're going to get our snowfall in a couple weeks. But this was really, you know, April time frame when we start to get our ground to thaw. So then you've got this period here where we grow, our turf is growing. We got that one event that I showed you before that happened with that 8.5 inch rainfall. But the majority of our phosphorus was lost when the ground was frozen. The majority of our phosphorus that was lost was also soluble, not total, or soluble as a large percentage of the total amount that came off. So here are the treatments. Here are the total amounts that came off, the total phosphorus amounts that came off in pounds per acre, and as a percent of applied. Here is the soluble phosphorus that came off. Again, the totals over here by treatment and as a percent of applied. So you can see that the majority of our phosphorus that came off in the form of soluble phosphorus. Comparing these numbers, going back here, just remembering these numbers here, 0.4 to 1.22, you know, we do have some comparison numbers for various types of land uses. And when you look at the turf data that was available looking at phosphorus runoff, we were higher than those numbers, and this was out of Wisconsin. We were certainly higher than those numbers, but that was equated to this growing year. We put a lot more phosphorus into these plots during that growing year than what Dr. Cousseau put in on these plots that he managed or watched the turf phosphorus runoff. Okay, so now this is 2006, same type of graph here, runoff events, soluble phosphorus expressed as milligrams, the same treatments, but remember, these were reduced at this point in time, 0.33 and 1. I apologize for the labeling there. This is 0.33 pounds of P and this is 1 pound of phosphorus. There is a difference that you can probably pick up here looking at, first of all, the frozen soil. We had a lot of phosphorus coming off. But we also had some large events that occurred through the time when the ground was thawed. And we also are starting to see this control plot here really start to creep its head up. And that control plot is no fertilizer at all. So look at these events over here. Of course, these events, you can again go back to the rainfall events, 2.5 inches and 5 inches, where we got the large amounts of runoff occurring when the ground was thawed. But if you look at it from a tabular standpoint, we actually reduced the amount of phosphorus coming off. We reduced the amount of phosphorus we're putting on also. But look at these numbers, 0.21 for the no fertilized plots, no phosphorus plots, applying it at a recommended rate of 1/3 of a pound per year, and then here's the 1 pound. Again, the amount coming off in the soluble form was a significant amount. Comparing the 2 years, 2005 to 2006, putting it on the same scale, up to 700 milligrams of phosphorus, you can see that once we reduced the inputs, we significantly reduced the amount of loading off-site. So this is our growing year, and this is our maintenance year that continued from this point on. Just looking at the interaction between the soluble phosphorus in a frozen soil and in a thawed soil, you can see that we got the majority of our phosphorus coming off those plots in the form of soluble phosphorus. Same trend held true in 2006 with the frozen and the thawed. Looking at it by treatment per runoff event, the control, the 0 phosphorus, and the 1 pound of P in 2005 were not statistically different in the amount of phosphorus coming off of those plots. The plots that had the largest amount of phosphorus runoff came at the high fertilized, high phosphorus rates. Looking at 2006, so this is the second year of that study, the story significantly changed. The control, no fertilized at all, had the same amount of phosphorus running off statistically as the high phosphorus plots. And that of the no phosphorus and the other 2 treatments were not statistically different. So most of our phosphorus runoff was in the soluble form. The majority of our phosphorus runoff occurred when the soil was frozen. Approximately 85% of our phosphorus runoff occurred when the ground was frozen. In 2005, the phosphorus runoff was greatest from turf receiving high rates of P. In 2006, the no phosphorus had the same amount of phosphorus runoff as those receiving phosphorus fertilizers. And the no fertilizer plots in 2006 had the same amount of phosphorus runoff as those plots receiving the high phosphorus fertilizer inputs. Late fall fertilizers, which we've just now started to talk about, should not contain phosphorus. We're talking about it not containing, maybe not even recommending the late fall nitrogen, but we certainly see those superior winterizing fertilizer bags in our big box stores that have a large amount of phosphorus in them. In our area of the country, where we grow turf for less than a month with our temperature, we would not recommend a late fall phosphorus application, specifically knowing that 85% of our runoff, phosphorus runoff, occurs when that ground is frozen.
What's your definition of late fall?
In Minnesota, my late fall application will be no later than October 1st. Yeah. Going up to International Falls, that could be September 15th. Yeah. I know I flew through that, and I apologize, but Marty and I are sharing this period here. We've got a few minutes. If you want to do a couple of questions before we get into Marty's, that'd be fine. Tom, first.
So what do you attribute the phosphorus runoff from the control?
Oh, Tom, I like Kevin doesn't like to show the plots because it's hard to have the picture show. The density of those plots are going down dramatically. We're actually starting to we're getting very close to bare soil in some spots. We have not measured particulate phosphorus in these plots yet, but next year we will start to on these control plots because we will start eroding or moving soil off of these plots that don't receive any fertilizer.
It's a volume or runoff issue. The volume is substantially greater on the unfertilized plots, and I'll show you some data in a couple minutes.
The runoff data seems like a little bit of a misnomer. You're actually measuring the snowmelt runoff. Is that true? You're showing
How are you defining the runoff then? I'm defining runoff as water moving off a surface.
A precip graph, but it's not your winter condition is snowmelt.
My winter conditions are definitely snowmelt.
So it's not the same. The pre, you have
It's the reason why I kind of